Prepping your air compressor for cold weather. Eric Lunsford, President and CEO of Pye-Barker Engineered Solutions, talks about preparing your air compressor for cold weather. Imagine that you're settling in for the biggest college football game of the year on a nice Saturday. Your drinks are cold, your snacks are hot, your friends and family are all gathered around. Then, just before kickoff, the phone rings. You don't want to answer it, but you can see that on the line is the SATA production supervisor. So you take the call. He says that the air compressor hasn't started this morning, and the only difference between Friday's production run to Saturday morning is the freezing temps that hit overnight. Even though Saturday is a live production day for him, he's got no machines running and he's got nobody working. And despite the fact that you were all prepped for the college football game, he needs you to come down to the plant at SAP, figure out what's going on, get it fixed, and get the plant running again. Now I know that seems far-fetched, but we hear stories like this all the time. I don't want that to happen to you. So in this article, I'm going to outline the top 7 steps that you can take to prepare your air compressor for cold weather. Step 1. Check your condensate drains. I'm talking about the condensate drain that's on the water separator on the compressor. I also mean the drain on the dryer and the drains on receiver tanks. First of all, if they've got strainers on them, you want to make sure the strainers are not plugged with rust or dirt. They're a guard, so whatever the strainers catch, it's to protect the drain. The key is to make sure that your strainers are clean and your drains are working properly. And you want to make sure, if possible, to get a heat source on it. If temperatures fall into the 20s, you may want to use heat strips or maybe just a heat lamp. The last thing you want is for the moisture separator to fill up with water that then freezes. Then the compressor can't work. It'll just unload and load. It continues to build up. We've seen where pipes actually become clogged completely with ice. It happens quickly because it's compressed air. You get a lot of condensate from compressed air. It's good routine practice to make sure that those strainers are clean and the drains are working. On dryers, you get rust from the pipes that go to the dryer drains. If those drains clog up, then the dryer can't drain the water and you get moisture downstream. You also want to check your filter elements too, just to make sure those drains are working. Usually, you find out a drain isn't working because you start getting water or oil downstream, mainly water. It costs a lot of money for your production or equipment to be down. It costs tens of thousands of dollars to repair equipment that's damaged because you've got condensate in the air. So it's always a good idea to check and make sure there's no condensate in your bowls. Your equipment usually has bowls, moisture bowls with little filters. Those are just incidental contact. They're not fine filters. But if you see oil or water downstream, you've got a problem with your dryer or a drain. If you've got oil, that oil is no good. That's been run through pipes and has picked up all kinds of debris. That oil needs to get out of your pipes, because if not, it'll do damage to your equipment. Step 2. Check your downstream air dryer conditions. Make sure your condenser on your refrigerated dryer is clean. If your dryer shuts off on high pressure, more likely than not, the condenser is clogged. If the condenser is clean, then it could be a fan motor. On your dryers, especially in cold winter temperatures, you want to make sure the mufflers are replaced. I would replace them as soon as it gets below freezing, because what happens is, if you get back pressure because of clogged mufflers, it can only be 10 or 20 pounds of pressure in your regenerating tank. And that causes an increased dew point because you can't purge the air out of the tower that's regenerating efficiently. So you want to make sure you check your mufflers or replace them. It's a simple thing to do. For people who have dryers that don't have a dew point monitor on the dryer, we would recommend getting a dew point monitor, because you never know until it's too late, until you start getting water downstream, that there's a problem with the dew point going to the plant. It's a nice portable unit. It's 110 volts, and you tie it right into the discharge outlet of the dryer and it tells you the dew point and it monitors the dew point all the time. It's got dry contacts on it in case you want to put an alarm on it. It's so vital to your operations. A dew point monitor is an excellent idea. An excellent tool to tell you what's going on. If you get water downstream, especially in the cold wintertime, you're going to start freezing pipes outside. If it stays below freezing for a couple of days, there's not much you can do even if you're heating pipes. You're just melting ice and sending it downstream and freezing it somewhere else. With a refrigerant air dryer, I think the first thing you want to do is make sure it's actually on and working. A lot of times you can flip the switch and the fan comes on but the compressor doesn't come on. So you want to make sure you're pulling down to where you're supposed to be on the suction gauge. You want to make sure your drains are actually operating. You want to make sure the fan is working within low temperature situations. Now, if you get too cold, a lot of the bigger dryers have a low pressure switch, so you can actually turn the dryer on. It will not come on because it's under low pressure because of the low temperature. It's not going to come on until that low pressure switch trips and tells us it's okay to start running. Some of the smaller ones, you just have to keep them off because they will freeze up. They don't have any low pressure protection. If that happens, hopefully you've got a bypass and can go around it. It's not good for the moisture situation, but at least you're getting air. Sometimes you just leave the valves open and let the hot air run through it, and eventually it thaws and the drains take care of it. With the desiccant dryers, the mufflers need to be changed and you need to make sure it's switching properly. Step 3. Make sure your air intake openings are protected from rain and snow. You want to check your intake boot. You want to check your inlet on your intake to make sure that it's not pointed upward. We've seen some situations where they come from the factory that way, where the intake is actually turned to the side or turned up. It actually would suck in moisture, and moisture in bearings is not good. It'll prematurely take out your compressor. You want to turn them down. And you also want to have at least a roof over your compressor. Most of the customers we see have their compressors under a roof or protected, and they've got the heavy-duty filters to prevent moisture getting to them. Sometimes it gets pretty close with compressors that are close to the drain for the roof and it's just pouring off the side of the roof. But if your intake filter gets wet, it also restricts your airflow. If it gets wet enough, you could cause that paper to start coming apart. You just don't want moisture getting in your compressor. Another thing is, if your compressor is running below 165 degrees or 160 degrees, you may develop a little moisture in an oil tank. You always want to make sure if it's running that cold, you probably need to either put a higher thermostat in or have that compressor enclosed a little better so that some of that heat stays in the room and the machine can run a little warmer. Step 4. Check and change your filters regularly. With the winter months and colder weather coming in, it's important to check and change your filters. The main thing is your air filter. If your filter is clogged, if it gets really dirty, it can cause a compressor not to operate and compress properly. You're just restricting the flow so it can't pull the air in to compress it. So you want to make sure that your filters, especially your air filters, are clean. Just periodically check that. If we're doing scheduled maintenance for a customer or they're doing it themselves, of course, doing it on time is the main thing. I can tell you a little story about a concrete plant that had a paper element. It had gotten so clogged and so dirty that it actually sucked some of the element out of the plastic housing into the intake of the air compressor, and we had to dig it out. So that's something that a customer probably should have picked up on. If the air filter has gotten that dirty, just keep an eye on things like that and be aware of it. Let us know, or get an air filter yourself. Step 5. Check the weather stripping and the insulation. Those compressors up north are kept in a room. Down south, we don't see all that much in the way of weather stripping or insulation, which is why we recommend a heat lamp. That's primarily what we see. And if you do have one, it's a good idea to check it or at least plug it in. When we have customers that we know will be getting temperatures in the 20s, we'll shoot them a text to tell them to make sure their heat lamps are plugged in. Otherwise, lo and behold, they go home for the weekend and the heat lamps are not plugged in, and they get temperatures in the 20s, and they've got a control issue on Monday morning at 5 a.m. and the phone's ringing. So keep an eye on the weather and what you have for winterizing. At the minimum, have a heat lamp in the area of the controls. If you don't put a heat lamp on, you may have control issues. When a compressor is running at a good temperature, you're trapping moisture in your control lines. It's just the nature of the beast. It's inevitable. They all get it. Then you shut the machine off. Maybe for a Christmas holiday. It's been running all month. Then you have a couple, 2, 3 days off and you've had a cold snap. The condensate gets trapped in the control lines and freezes. And then it blocks the signal, what the compressor is supposed to do, whether to load or unload or blow down, things of that nature. How do you get that condensate out of those control lines? Turn a heat lamp on and let it dissipate and evaporate. You get moisture. That's just the way it is. And that's exactly what happens. We've had to actually take parts off of compressors and thaw them in the truck because they were just frozen. It was all frozen. And of course, this was up north. But there's no other way you can do it. You're just going to compound the problem with no heat in the compressor room or outside. Just put a heat lamp on it. That'll take care of it. It'll keep it warm enough where that moisture can flow. When it needs to get out of that control line through either a regulator or a control filter drain. Step 6. Check your receiver tanks. Should you be worried about condensation in your receiver tanks when it gets below freezing? Absolutely. That's one of the places. The receiver tank collects almost all of the condensate. A lot of it's dropped out with the moisture separator. Probably 80%, but then when it gets to the receiver tank, you get a lot of moisture. We've had customers say, "Oh geez, we've got water downstream." Well, you're sending all that water and the tank is filling up. You've got a 400-gallon tank and it fills up and you go to use your air hose. You put your air hose on the side of the tank and all you get is water. And it's like, what the heck's going on here? 50 horsepower and above. I would not recommend putting a time drain. You've got a little screen, a strainer, and it doesn't take much corrosion to clog it. Then your drain can't drain the water. We recommend a zero-loss drain that'll handle the load of water you're going to get. You can see the water that's being drained. You can see it in the little holding tank on the drain. It's a very reliable drain versus the timer drains. Customers like the timer drains because they're inexpensive, but they can't handle that load of moisture. By the time you've replaced those timer drains once, twice, 3 times a year, you could have bought one of these other drains. It's so reliable, it'll probably last you 5, 10 years, and it could even go beyond that. Timer drains are good for your filters. Anything below 50 horsepower, you can put them on the filters in your tanks. You do get a lot of corrosion that falls out in the receiver tank. Check your strainers, especially if it's an older tank. You're going to get a lot of corrosion in there and it plugs up. A lot of times you don't even get to the zero loss because the discharge on the bottom of the tank has plugged the pipe solid. It's a pain to get that clean, so if you get it clean, try to stay on top of it. If you pull a strainer out and it's completely clogged with rust, our recommendation is this: don't just clean the strainer and put it back in. There's a little valve before that strainer. Just crack it and slowly open it so you can purge that out. Because what's going to happen is there's going to be rust in there and there's going to be bits of corrosion. It's going to just clog that strainer right back up again. So if you go in there and you clean the strainer, you could put it back and say, "Oh good, we're good." And a day later it's clogged again. Or it could be a half an hour later. After a couple cycles of the drain, that time drain is going to have a hard time catching up and trying to get rid of all that condensate that's in that tank. If it's got 20 gallons of moisture, turn that drain down so it goes off every minute. You can either drain the whole tank manually, or you can turn up the drain to where it drains every minute for 15 seconds, 30 seconds, until that tank is empty. Then shut the valve, check the strainer again, and readjust it to every 7 or 8 minutes for maybe 5 seconds. Step 7. Check your lubricant and test it for water. Lubricant is the lifeblood of the machine. There are customers that we test regularly, but it's primarily not for moisture. It's for acid. Acid is the killer in the polyglycol blended fluids. With the polyglycol fluid, moisture actually blends in with the fluid. It doesn't separate out like with a POW, and that's what causes acid in the machine. So, yes, get it tested, not just for water concentration, which is an issue in the wintertime, but for contaminants, breakdown of the oil, varnishing, and so on and so forth. We're very adamant about taking oil samples. If you use a POW synthetic or a polyglycol, you can get 8,000 hours out of it. But there are a lot of things that the compressor ingests, whether it be exhaust fumes from diesel, welding fumes, chemicals, chlorine, sulfur, anything like that, that can cause harm to the additives that are put in, especially polyglycol, but also POW fluids. Now, polyglycol has an extra additive to it, and what that does is that starts your acid number a little higher than your POW oil. And what happens with polyglycol is that it will actually absorb, blend chlorine, blend diesel fumes, welding fumes, any kind of chemical exhaust. It will actually blend and degrade that polyglycol. We've seen it where it turned to complete acid and ate through pipes. So that's why it's important. We at Pye-Barker offer our Gardner Denver products. Gardner Denver does have aftermarket polyglycol, and it's a very good product, but you still have to sample it. And Gardner Denver provides that service free of charge on our aftermarket products that we offer. Lower-priced lubricants for older machines, we also offer free oil analysis for that. So we stand behind our products and we're firm believers in making sure that your equipment is protected, because that equipment costs a lot of money to purchase, and you want to protect it. You stretch the oil filter, you get particles in the oil, then it goes through the separator, you shorten the life of the separator. you shorten the life of the oil. That's why we take those samples to get the total acid number and also to check for particulates in the oil. For phosphorus, for viscosity. Just make sure that everything's okay with your oil where you're not running the oil and it's actually being detrimental to your compressor bearings. That covers our 7 steps for prepping your compressor for the cold weather. You may wonder, what kind of effect does the colder intake air have on the compressor? What happens to the operation of the compressor when the temperature drops into the 20s? Basically, on a reciprocating compressor, the effect is marginal. In the worst case, it doesn't do much. Your compressor has a thermal valve, so it's going to take that air and it's still going to heat it up. Heated compression is rapidly raising the temperature. The only concern you have is if you have a turbo compressor. You're better off with colder air than hotter air. Hot air is less dense and it's not as efficient. Cold air shouldn't affect your compressor much at all. At Pye-Barker, we're here to assist you. We can help you out, whether it's with your compressor, whether it's with piping issues, whether it's with downstream air quality, or proper applications for your equipment. We're here to help you out. Email me at eric@pyebarker.com or call me at 404-738-5810 and we'll get a cold weather assessment scheduled for you.